In this project, we're evaluating the independence of working memory for scene layout and simple features. So in everyday life, we see discrete objects alongside the large extended surfaces of a scene. And there's evidence that different brain regions are specialized for processing surfaces versus objects, which might lead you to believe that there's also different memory stores. But most working memory experiments focus on discrete objects, and the few that focus on scenes contain objects in their scenes, preventing a strong dissociation between the two. So here we're using a dual task paradigm, and we're asking how independent representations of objects versus large extended surfaces are. And the idea is that if there's less of a dual task cost, then that's evidence for more independence. So in our first experiment, we looked at dual task performance in a memory task, and we had participants remember an array of colors, plus either an oriented Gabor or a scene image, and we approximately equated performance for the Gabor and the scene parts of the task. And we were asking how much of a cost there was on color performance when doing the Gabor task at the same time, so another basic feature, compared to doing the scene task at the same time, which contain large extended surfaces. So in trials where participants reported the color, they had higher performance when the extra item was a scene than when it was a Gabor. And when they were asked to report the extra item, there was no significant difference between the Gabor versus scene judgment, although they were numerically better at the scene judgment. So this suggests that there is a smaller dual task cost for remembering a scene and spatially discrete features versus two different types of spatially discrete features. But next, because single task performance is at ceiling in our initial study, we wanted to get it off ceiling so that we could more precisely measure dual task cost relative to single task performance. And we also wanted to add a third extra item condition, color, to compare costs within the same feature to costs across different types of features, and hopefully use this as a benchmark for our scene feature dual task costs. So now I'll show you an example trial of our memory paradigm. First, we showed participants an array of central colors, and then after a brief delay, we showed them one of three extra items: an oriented Gabor, a color, or a scene. Then after a memory delay, we test their memory. And if this is a single task block, participants are tested only on a given extra item, for example, scenes, or on the central colors for an entire block. And if this is a dual task block, participants are 50% likely to be tested either on a given extra item, so a scene, for example, and 50% likely to be tested on the central colors. And the extra item is blocked in this case as well. So here's our basic analysis approach. On the x-axis, I'm plotting performance for remembering the central colors. And this dot on the x-axis is showing hypothetical performance when that's participant's only task. And the dot on the y-axis is showing extra item performance when that is subject's only task. And we'll compare participants' dual task performance to two basic models that are based on their single task performance. So if there was completely separate memory for the colors and the extra item, you'd probably expect something like this unlimited capacity model. So that open circle is dual task performance, and you can see there's little, if any, cost compared to single task performance. And if the dual task cost is so large, participants can effectively only remember one type of information. You might expect something like this all or none model with a one-to-one trade-off in performance between the two tasks. And performance might also be somewhere in the middle. So our main measure for each condition is the proportion of distance this dual task performance is between the all or none and the unlimited capacity models. And I'll be calling that the proportion independent. So one prediction is that an extra color memory item might have a large dual task cost remembered alongside the central colors, since color stimuli presumably draw on the same resources. And we might expect more independent representations for Gabors alongside the central colors, since there's evidence those two draw on separate resources. And we ultimately want to ask how dual task costs for scenes compare, so you might expect the cost to be similar to Gabors, since large surfaces are generally defined by orientation information, or you might expect performance to be even more independent if they're processed and stored with separate resources. I'll be showing data collapsed across two data sets where I was able to roughly equate performance in the single task conditions, which you can see at the top of the y-axis. So here's the dual task data. And first you can see that for all extra item conditions, there was a huge dual task cost, so performance is very close to the diagonal lines. And you can also see that there don't appear to be significant differences between the conditions. Next, I'll show you plots of the proportion independent by subject, since it's possible that this would be a more sensitive measure that's able to pick up on more subtle differences. And in this plot, each point is a single subject's data. And you can see here there's no significant difference between any of the conditions, and the data is pretty noisy. So the main thing that jumps out about this data is that there's no dual task difference for the Gabor and the color extra item conditions. It's possible that this is due to noisy data, but it's also consistent with recent questioning of separate representations of color and orientation. And it's also possible that remembering an extra spatially distinct item is adding a large cost in all conditions, swamping any effects of feature or category-specific memory resources. And our next step is a higher powered investigation of Gabor and color dual task costs, which may be interesting in itself, and it may also give us a more refined paradigm and a baseline we can use to ultimately ask about dual task costs for individual items versus scene surfaces.